This is a brief outline of what I'm going to be going over today. Introduction and theory of what a Rankine cycle is. The objectives, apparatus, procedure of the experiment. Equations that can be used, my own predictions, and then see if there's any questions at the end. Okay, this is a basic diagram of a Rankine cycle, and then that is the temperature versus entropy graph for an ideal Rankine cycle. Basically, we all know what it is from thermo. It has four subsystems: turbine, condenser, pump, and a boiler. It's used as the ideal system for vapor power plants to produce energy. So basically, the fluid comes through the pump, and it enters the boiler as a saturated liquid. The boiler will heat up the fluid and then leave to the turbine as a saturated vapor. Turbine is obviously what produces the electricity, or electric power. By the working fluid will rotate a shaft which is connected to a generator which outputs the power. And then the fluid is cycled back to the condenser, which obviously condenses the fluid by circulating and cooling water. Then goes back into the pump as a as a saturated liquid. The graph is, again, as I said, is an ideal graph for a Rankine cycle. 1 to 2 is the pump, 2 to 3 is the boiler, 3 to 4 is the turbine, and then 4 back to 1 is the condenser. These are the main objectives of the lab, just doing some calculations from the measurements found, find the mass flow rate, the work from the pump, the boiler heat input, the removed heat from the condenser, the turbine work, the turbine efficiency, and the cycle efficiency. And then we're also going to observe the difference between a theoretical and an actual Rankine cycle. This is the actual apparatus. We're going to be using the boiler from the university. And you can see all four main subsystems: the turbine, condenser, the pump, the boiler, and then back to the turbine. These 6 marks with a P, and then a number next to them is where we're going to be making our pressure and temperature measurements. This is the basic procedure. I'm just going to go over a brief outline of it. Before we actually start, we're going to check all the valves, make sure certain ones are on or off, and then make sure the bearing and the governor oil levels are correct. Then we're going to apply the first load, which is 8 bulbs at 25 watts each, and then measure 6 pressures and temperatures at the locations I stated before. Then also measure the initial generator output and the system flow rate. Then after those are recorded, we're going to close valve 5, where the water on the valve meter will increase to 50, and then we'll record those final fluid levels. Then we're going to open valve 5 back up, allowing the flow meter to reach the lowest mark, and then repeat these 3 times. And after that's finished, we'll apply the second load, which is twice as big as the first load, and then repeat the previous steps. To turn everything off, we're going to turn off the first load, leaving the second one on, and then open and close whichever valves are supposed to be open or closed, and then wait for the pressure at 1 to go down to 0, and then turn off the other load. These are the basic equations that can be used. Obviously, to find the pump work in, the pump exit enthalpy, the boiler heat, the condenser heat, the turbine work, turbine efficiency, and the overall cycle efficiency and electrical power. These are the predictions I made. I said that the temperature at the condenser was 1 atm, and then the highest recorded pressure, according to the lab manual, says that it was recorded at 100 psi. So I went ahead and assigned that to the pressure at the boiler. And then I calculated the enthalpy at each 4 location, assuming that this was an ideal Rankine cycle. I came up with a low percent of 14% efficiency. Any questions? Any questions about my efficiency?
That's what I was.
Yeah.
That's what I was.
Why is it so low? Okay, so I used an example from the thermo book.
Okay.
That was an ideal. so low is because the pressures aren't, like, there's not a vast difference between them. They're
Okay.
not, you know, very different. I think if either the condenser pressure was lower or the boiler pressure was higher, it would be a higher efficiency,
Okay.
causing more heat from the pump and the
Yeah.
turbine.
Yeah, I just, like industrial ones that, used are around
Yeah,
like 30 or
Yeah.
30%.
Yeah.
So,
and that was the example for the book, had
Okay.
30%. And,
yeah, I was just trying to figure out how I wanted to answer the question. So, good job
okay.
being proactive.